Terraform modules are fundamental components of good infrastructure as code. They allow you to reuse code and share it with others. In this video, we'll see how you can use the Firefly platform to build and use modules on both existing and new infrastructure. What's up, everybody? It's Ned Bellavance, nedinthecloud.com. Welcome to another Terraform Tuesday. In this special sponsored episode, I wanted to cover how you can use the Firefly platform to build modules for unmanaged and codified infrastructure. You can also use their Firefly AI feature to build net new modules that you can use to deploy fresh environments. But before we get into how Firefly can help with building and using modules, I think we need to talk a little bit about what modules are and what makes a good module. At their most basic level, Terraform modules are simply a directory with a Terraform configuration in it. Nothing fancier than that. If you're deploying an environment directly from that configuration, then we refer to it as the root module. Your root module can use the module block to create child modules. And these modules can be sourced from a local directory, a remote repository, or a registry. The Terraform registry is a public repository of modules that you can use in your configurations. Values are passed into a module using input variables, and the module can return values using output values. The resources and data sources managed by the module are not directly exposed to the parent module, which is part of the abstraction that modules provide. So, why use modules in the first place? Terraform modules are like many other abstractions in programming. Think of libraries in Python or packages in Java. Each provides an abstracted set of functionality you can use in your code. Modules provide an abstracted set of resources, data sources, or sometimes even local values that you can use in your Terraform configurations. Terraform modules are reusable across multiple configurations, and if you stored them in a registry, you can share them with others and support versioning of the modules. Most companies that adopt Terraform build up a library of public and private modules used across their organization. The modules not only provide a way to share code, but they also provide a way to share best practices and organizational standards. So what makes a good module? Well, there are a few things to consider. First, a good module should be reusable. That's kind of the point of modules. It should be composed of a logical grouping of resources or data sources that are commonly deployed and managed as a single unit. A great example of this is the VPC module from the Terraform public registry. A VPC in AWS is way more than just a single resource. It can include subnets, an internet gateway, route tables, and lots more. The VPC module groups all of these resources together into a single module that can be used to deploy a complete and functional VPC. A good module should also be composable. You should be able to combine it with other modules and the root module to deploy useful infrastructure. Our VPC module can be used in tandem with an RDS module to deploy a database in a private subnet. And then it could be used with an EC2 module to deploy a web server in a public subnet, building out a whole application infrastructure. Third, a good module should be configurable with sane defaults. It should have a sufficient number of input variables to customize resources as needed, while also making some reasonable assumptions that follow generally accepted best practices. The VPC module, for instance, assumes that you don't want NAT gateways right away, unless you explicitly tell it to create them. That could save you a ton of money. Finally, a good module should be well documented. It should have a README that explains what the module does, how to use it, and what input variables are available. It should also have a change log that documents the changes to the module over time, and it should have some examples that show how to use the module in a configuration. HashiCorp maintains a public registry of modules at registry.terraform.io, And there are over 15,000 modules on the registry right now, with more being added every day. With such a large selection of modules matching a wide variety of use cases, you might be wondering if you even need to bother with writing your own modules. The answer, of course, is it depends. Generally speaking, most of the common use cases are well covered by existing modules. Before you go down the road of designing your own module, I highly recommend looking through the public registry and seeing if there's a module that meets your needs. If there is, then you should just use it. If not, there still may be a module that is close enough that it provides you with a good starting point. All of the modules on the Terraform public registry are open source, so you can fork them and modify them to meet your needs. If you do this, I highly recommend submitting a pull request back to the original module so that others can benefit from your changes. But even if you can't publish your changes back for privacy or internal company reasons, starting with an existing module will greatly lower the work effort required in writing your own. If you can't find a module that meets your needs, then you can write your own, but like I said, starting with a blank slate is hard, and that's where Firefly comes into the mix. Firefly is a SaaS platform that provides a GUI for managing Terraform configurations. It also provides a number of features that make it easier to manage Terraform configurations at scale. One of these features is the ability to build modules from existing infrastructure. This is a great way to get started with modules, and it's also a great way to build modules for existing infrastructure that you want to manage with Terraform. If you haven't watched my previous video on Firefly, I definitely recommend checking it out. But the short version is that Firefly can help you codify existing infrastructure and bring it under management by Terraform. It can automatically generate a configuration for you and push the code to a repository. Then you can use your standard workflow process to import the configuration into your Terraform workspace and start managing it with Terraform. In the previous video, we codified infrastructure as is, but a cool option is to codify infrastructure using an existing module, either one you wrote or one from the public registry. If you're trying to standardize on modules and bring existing infrastructure into the mix, this is a good option. Let's take a look at how it works. I've already deployed an existing VPC using CloudFormation. Now I want to start managing it with Terraform and use the VPC module from the public registry. For starters, I'll use the inventory view in the Firefly UI to filter on unmanaged resources. These are resources that Firefly has gone out and discovered in AWS and realized that there are no corresponding state files that have those resources in them. I can further filter on my AWS account and then on the US East 1 region. All right, cool. It looks like I've got an unmanaged VPC here. I'll select all the associated resources, and then I'll click on the Codify button to start the process. Now, by default, it's going to codify all the resources in a root module, but let's select the module call option. From the drop-down menu, I'm going to search for and select the VPC module from the public registry, and then I'll have to pick the correct submodule from the two options that are here. From there, it quickly constructs a module block with all the necessary input variables and values that match my existing infrastructure. Since our resources already exist, we are going to want to use an import workflow to bring them under management by Terraform. So I can toggle the import blocks option to add those to the configuration. From here, we could create a pull request targeting a repository or download the code, make some tweaks, and push it up to a new repository. That's how you can go about using an existing module. But what about creating a new module? Instead of using a module to codify unmanaged infrastructure, you can also use Firefly to create a module based on existing codified resources. This is a great way to refactor your code to start using modules in your organization. Let's take a look at how it works. For my module, I would like to create a compute module for some EC2 instances and Elastic Load Balancer I have deployed. I'll use the inventory view and filter on codified resources. It's going to maintain my other current filters for the AWS account and region. So now I'll see a VPC, some EC2 instances, and a load balancer configuration. Out of that list, I'm going to select the EC2 instances, the load balancer components, and the security groups that govern the traffic going to those instances and the load balancer components. Now this time, instead of doing a module call, I'll pick the create module option, and Firefly will think about it for a few moments. When it's done, it will create a series of module files, including a main.tf, variables.tf, output.tf, provider.tf, and example.tf. Looking through the main.tf file that was generated, it looks like it included the VPC components as well. So we're going to need to do a little bit of tweaking for this module. It has also generated variables for most of the arguments in each resource. Scrolling through, it's done a pretty nice job of setting the type for each variable, setting a default value, and creating a useful description. The outputs include a lot of information that we might want to use in a configuration that implements this module. The example file shows how to use the module as is, and the provider file includes the required version of the AWS provider and an AWS provider block. Now, we probably want to remove the provider block from this module, since the module is going to inherit the provider configuration from the root module that invokes it. Essentially, what Firefly has done is give us a huge head start on writing a module that mirrors what we have in deployment. The next step would be to export all the files and work with them locally to tweak the module until it meets our needs. Then we can push it to a repository and start using it in our configurations. Whether you decide to write your own module or modify an existing one, a common question is that of where to start. How do you decide where the boundaries are for a given module and what resources and data sources should be included? This is where the concept of a module design pattern comes into play. There are three important considerations to keep in mind when deciding on the scope of a module. The first is grouping together resources that form a logical whole. Now, we just saw that with the VPC module incorporation into an existing configuration. The VPC module groups together all the common networking components that would support one or more applications. But you'll note we didn't include things like security groups. That should be part of the application. The next module design pattern is to group together resources by lifecycle. Now, this is a common pattern for modules that deploy a single application or a portion of an application. And we just saw that with the EC2 instances and the load balancer pieces. The components of a web front end will generally follow the same lifecycle, and a web front end is a common enough pattern that it can be broadly reusable. Creating a web front end module provides the opportunity to enshrine some best practices while simplifying the deployment for other teams. The last module design pattern is to group together objects that perform a common function. For instance, you might develop a module for creating IAM roles, policies, and maybe accounts for S3 bucket access. This module would be reusable across multiple configurations, and it would allow you to standardize on a common approach for managing S3 bucket access. There is a larger conversation to be had about when to break up a configuration into multiple related configurations, but that's a topic for another video. For now, let's take a look at how you can use Firefly to compose new configurations or update existing ones with modules. Firefly can also help you write new Terraform configurations or update existing ones using either an existing module or by creating a net new module that leverages AI. Let's take a look at both examples. In this example, I want to update my existing configuration to include an IAM account. From the left-hand navigation pane, I will select Compose and make sure that module call is selected. For the existing module, I am going to pick the IAM module from the public registry. It's in the Terraform-aws.im parent module, which is all the way down at the bottom. There we go. and I'll select the module and submodule that I want to use, which is the modules/IAM account. Once I select the submodule, Firefly will automatically load the input variables along with their default values. The only required variable value is account alias, so I'll give the account an alias of TacoBot and click on Generate down at the bottom. Now, once the module block is generated, I can click on the pull request button to add this code to an existing configuration. I'm going to pick my GitHub integration, which has access to my GitHub account, and from there, I'm going to pick the AWS-Terraform-example repository, and then click on the Create button to create a pull request targeting the main branch of the repository. Firefly will provide me with a link to the pull request, which I can click on and review the changes. Looking over in GitHub, the pull request includes a new file containing the code that was just generated. Now, depending on your automation solution, the pull request could generate a speculative plan for review and approval. And if I merge the pull request, an automation solution could kick off an apply run to implement those changes. That's pretty cool. Now, what about this AI thing? You may have noticed the AI option in the Compose window. You can use that to create a new configuration from scratch using AI. Let's take a look at how it works. Let's say I wanted to create a Lambda function that will be triggered by an object being added to an S3 bucket. I'll click on the Compose button and select the AI option. I'll type what I want in the message field using the starter text that's included. It says generate Terraform template for, and I'm going to add some text here, an AWS Lambda function that is triggered by an S3 object being added to a bucket. Once I have all that text in, I will hit enter and wait for a few moments. In the right pane, I now have a main.tf that not only creates the Lambda function, but it also creates the necessary IAM role, the role policy attachment, the S3 bucket, and the bucket notification. It also wrote the Python code for me with a stub that will print out the name of the object being added to the bucket. Now, everything here is hard-coded. So what if I want to add some input variables for the bucket name and the Lambda name? Well, the AI keeps track of the context of the conversation, so in the field, I'll type in add an input variable for the function name and S3 bucket name and hit enter. After a few moments, it has now created a variables.tf file and updated the associated references in the main.tf file. And I can continue like this, tweaking and updating the code until I have a configuration or module that meets my needs. Then I can create a pull request or download the files locally and keep working. This is quite the time saver. If the first step of using infrastructure as code is to codify existing infrastructure, then the second step is to start using modules. Modules are a critical component of Terraform and the next step in your IAC journey. But that doesn't mean you need to build your own modules from scratch. Far from it. There are a ton of modules on the public registry, 15,000, remember? And you should use them if you can. Even if they don't meet your exact needs, they can be a great starting point. Firefly's platform can help you integrate new and existing modules into your infrastructure as code. That could be applied against unmanaged infrastructure or used to refactor the code for existing managed infrastructure. Either way, using Firefly can save you time and effort in building and using modules. And if you need help building a new module from scratch, Firefly's AI feature can help you get started. It can generate a configuration for you based on a description of what you want to build. Then you can add additional comments to have it further tweak the code for you, or download the code and update it yourself until it meets your needs. If you're interested in trying out Firefly, you can start a free trial by going to firefly.ai. I'll include a link down in the description that will take you right to the trial page. You can also check out my previous video on Firefly to learn more about the platform and how it works. Big thank you to Firefly for sponsoring this episode and for supporting the channel. Lastly, big thanks to you for watching. There's a ton of great Terraform content out there, and I appreciate that you chose to spend some time with me. Until next time, stay healthy, stay safe out there. Bye for now.